Dear students, good morning. Today's class I will be teaching you Ampere Circuit Law for time varying fields and the concept of displacement current. So first I will write what is the Ampere Circuit Law in point form for steady magnetic fields. The Ampere's Circuit Law for steady magnetic fields. For steady magnetic fields is del cross H is equal to vector J. This I will call equation 1. The Ampere Circuit Law should be consistent with the equation of continuity. The Ampere Circuit Law should be consistent with the equation of continuity given by del dot vector J is equal to minus dou rho V by dou T, equation 2. What I said is, the Ampere Circuit Law for steady magnetic fields is del cross H is equal to vector J. Here J is called conduction current density. The Ampere Circuit Law should be consistent with the equation of continuity given by divergence of vector J is equal to minus dou rho V by dou T. For steady fields, rho V, dou rho V by dou T equal to 0. Hence, equation 2 reduces to divergence of J is equal to 0. This is equation 3. Right? This is equation 3. Now, the Ampere Circuit Law is given by del cross H is equal to vector J. This is the equation of continuity. Let us take divergence on both sides of equation 1. If you take divergence on both sides of equation 1, what we get? I am going to write here. Let us take divergence on both sides of equation 1. Then what we get? We get del dot del cross H is equal to del dot vector J. What I have done? Del cross H is equal to vector J. I have taken divergence on both sides. Divergence of curl of a vector is 0. This implies del dot vector J is equal to 0 because divergence of curl of a vector is 0. This I call equation 1. I have slightly modified the Ampere Circuit Law for steady fields. It is del cross H is equal to vector J. I have taken divergence, means del dot on both sides of this equation. Divergence of curl of a vector is 0. Correct now? Because divergence of curl of a vector is 0, you get 0 is equal to divergence of J, or divergence of J is equal to 0. This I will call equation 1. Now we have formed a basis for comparison of equation 1 with the equation of continuity. For steady magnetic fields, dou rho V by dou T is equal to 0. Hence equation 2 reduces to equation 3. Now you see, since equations 1 and 3 are identical, del cross H is equal to vector J is okay, or it is consistent with the equation of continuity. I am going to write now, since equations, this I call, for better understanding, this I call equation 1, this I call equation 2, this I call equation 3, this I call equation number 3, this I call equation 4. Since equations 2 and 4 are identical, are identical, it implies Ampere Circuit Law given by equation 1 is valid for steady magnetic fields. Valid means consistent with the equation of continuity for steady magnetic fields. However, for time varying fields, dou rho v by dou t not equal to 0. Hence, equation 1 is not consistent. Hence, equation 2, please note that equation 1 and equation 2 are same, but they are in different forms. Hence, I am going to say, equation 1 or equation 2 is not consistent means equation 1 also is not consistent. Hence, equation 2 is not consistent with the equation of continuity. That means equation 1 has to be now modified for time varying fields. This means equation 1 has to be now modified for time varying fields. This means equation 1 has to be modified for time varying fields. Let the modified Ampere Circuit Law for time varying fields in point form be given by del cross H is equal to vector J plus vector G. This is equation 5. Where vector G is the modification applied. Next our procedure is to find what is vector G. Taking divergence on both sides of equation 5 gives del cross H is equal to del dot vector J plus del dot vector G. Divergence of curl of a vector is 0. This implies 0 is equal to divergence of J plus divergence of G. This implies divergence of G is equal to minus del dot vector J. This I call equation 6. Substituting equation 3 is the equation of continuity. In equation 6 gives del dot vector G is equal to minus, what is divergence of J? Minus dou rho V by dou T. This implies del dot vector G is equal to dou rho V by dou T. This I call equation 1. The Gauss law in point form is, the Gauss law in point form is del dot D is equal to rho V. Del dot D is equal to rho V. This is equation 8. Substituting equation 8 in equation 7 gives del dot vector G is equal to dou by dou T operating on divergence of D. See, dou by dou T is time operator, del is space operator. They are linearly independent of each other and hence they can be interchanged. These two operators can be interchanged. Since space operator del and time operator dou by dou T are linearly independent of each other, they can be interchanged. Hence del dot vector G is equal to del dot vector dou D by dou T. This implies vector G is equal to vector dou D by dou T. This implies vector G is equal to vector dou D by dou T. Now I call this as equation 9. Let us substitute equation 9 in equation 5. Substituting equation 9 in equation 5 gives del cross H is equal to vector J plus vector dou D by dou T. This is same as vector J plus vector JD. This is called equation 10, where vector J is equal to sigma into vector E equals conduction current density. This is nothing but Ohm's law in point form, and vector JD is equal to vector dou D by dou T is equal to displacement current density. So in equation 10, vector J is called conduction current density and vector JD equal to vector dou D by dou T is called displacement current density. Both have got the unit amperes per meter square. Equation 10 is known as Ampere Circuit Law in point form for time varying fields. It is also called Maxwell's equation in point form for time varying fields as derived from Ampere Circuit Law. So I am going to write now. Equation 10 is known as Ampere Circuit Law in point form for time varying fields. time varying fields. Equation 10, this is equation 10. Equation 10 is also known as Maxwell's equation, in point form for time varying fields, as derived from Ampere Circuit Law. Very, very important derivation from the examination point of view and also from the subject point of view. Now let us understand what is displacement current. In order to understand the concept of displacement current, let us take open surface integrals on both sides of equation 10. So I am going to write now. So this I will wipe. In order to understand the concept of displacement current, let us take surface integrals. Let us take surface integrals on both sides of equation 10. Then what you get? Open surface integral del cross h dot ds is equal to open surface integral vector j dot ds plus open surface integral vector jd dot ds. So the first integral is conduction current. The second integral on the right hand side is displacement current. Applying Stokes theorem. To the open surface integral on the left hand side of the above equation. Gives contour integral C vector h dot dl is equal to sum of conduction current and displacement current. This is known as Ampere Circuit Law in integral form. Why it is called integral form? Because what is IC? Open surface integral vector j dot ds. What is ID? Open surface integral vector jd dot ds. This is called Ampere Circuit Law. In integral form for time varying fields. It may be noted that IC is equal to open surface integral vector j dot ds is equal to conduction current. ID equal to open surface integral vector jd dot ds is equal to open surface integral vector dou d by dou t dot ds is called displacement current. is called displacement current. So what is important is the displacement current arises only for time varying fields. For steady fields, ID will be 0 and Ampere Circuit Law will be contour integral, say vector H dot dl is equal to IC. Please note that the concept of displacement current arises only for time varying fields. For steady fields, ID is 0 and the Ampere Circuit Law in integral form will be contour integral, say vector H dot dl is equal to conduction current IC, which is the current enclosed. Note, ID equals 0 for steady fields. For steady fields. So this is a very important topic. Practice this as many times as possible. This will be asked in the examination for 8 marks. So be thorough with this derivation. Next one, very important problem I am going to do. The problem statement is show that for a parallel plate capacitor, conduction current in the wire equals displacement current in the dielectric. Very important problem. Dielectric, when the capacitor is subjected to a time varying voltage source. Very important. Show that for a parallel plate capacitor, conduction current in the wire equals displacement current in the dielectric, and the capacitor is subjected to a time varying voltage source. Solution. Let us take a parallel plate capacitor. Distance between the plates is d. Each plate has got an area equal to S meter square. The capacitor is subjected to a time varying voltage source. This is Vi of t is equal to Vm sin omega t. What we have to show is conduction current in the wire equals displacement current in the dielectric. That means there is continuity of flow. If the time varying voltage source is replaced by a DC voltage source, ID will be 0. ID will be 0 means IC will be 0. Therefore, capacitor cannot conduct when subjected to a DC voltage source. Conversely speaking, for time varying fields, ID will not be 0. In fact, we have to show that IC equals ID and ID again becomes equal to IC. Therefore, there is continuity of flow and capacitor conducts when subjected to a time varying field or a time varying voltage source. Very important problem. Let D be equal to distance between the plates. Capital S is equal to area of each plate. Distance between the plates in meters. This is in S is in meter square. IC is equal to conduction current. IC is equal to conduction current in the wire. Conduction current in the wire is what? dq by dt. What is Q? What is Q? Capacitance into Vi. Because how do you define capacitance? C is equal to Q by V. Or, correct, no, Q is equal to CV. This implies IC is equal to d by dt. C is a constant, I take out. C d by dt. What is Vi? Vi is Vm sine omega t. Differentiate this. So, what you get? C into Vm into omega into cos omega t. C into Vm into omega cos omega t. This is equation 1. This is the conduction current in the wire. What is displacement current in the dielectric? That is the next thing. ID is equal to displacement current. ID is equal to displacement current in the dielectric is equal to open surface integral vector dou d by dou t dot ds. This is nothing but dou d by dou t surface integral ds. This dot product is dispensed off or is dropped because vector dou d by dou t and vector ds are normal to each other. What is surface integral of ds? Surface integral of ds is nothing but s. So this implies ID is equal to s into dou by dou t. What is d? D is what? Epsilon into e. So this is epsilon into s dou by dou t. What is e? E is Vi of t divided by d. Unit of E is volts per meter. So E is nothing but potential difference between the two plates divided by the distance between the two plates. This implies ID is equal to epsilon into s divided by d, dou by dou t operating on what is Vi of t? Vi of t is Vm into sine omega t. Epsilon into s divided by d is the capacitance of a parallel plate capacitor. So differentiate this. C into Vm into omega cos omega t. This is equation 2. Equations 1 and 2 are identical. Hence, ID is equal to IC. Therefore, please note that you might be feeling that there is an open circuit between the two plates, how current can flow. The current will flow when the voltage in the two plates is a time varying source, because current in the dielectric equals current in the conductor. Whereas if you replace Vi of t by a DC voltage source, ID will be 0 and IC will be 0 and capacitor will not conduct. Therefore, capacitor does not conduct when subjected to a steady field. Please note this. However, it conducts when subjected to a time varying field. From equations 1 and 2, from equations 1 and 2, we find that conduction current in the wire equals displacement current in the dielectric. This means a capacitor can conduct only under time varying fields. Only under time varying fields. Under time varying fields means when the plates are subjected to a time varying voltage source. That is what I mean by saying under time varying fields. Thank you. The conduction current through a wire with a conductivity sigma equals 10 to the power 7 Siemens per meter is the unit of sigma, and relative permittivity epsilon r equal to 1 is given by IC is equal to 2 sin omega t milliamperes. Note the unit of current milliamperes. If F is equal to 10 to the power 9 by 2 pi hertz, find the displacement current. Solution. Let me read out once again. The conduction current through a wire with a conductivity sigma equals 10 to the power 7 Siemens per meter and epsilon r equal to 1 is given by IC is equal to tau sin omega t milliamperes. If F equals 10 to the power 9 by 2 pi hertz, find the displacement current. So what is conduction current? Conduction current IC is equal to JC into S. What is JC? What is J? What is J? J is nothing but conduction current. J is nothing but conduction current. What is S? Area of cross section of the conductor. S is the area of cross section of the conductor. J is conduction current density. What is the unit of conduction current density? Amperes per meter square. What is the area of cross section of the conductor? What is its unit? Meter square. So amperes per meter square into meter square gives you amperes. What is J? Sigma into E into S. This implies E is equal to IC divided by E into S. So what is IC given? IC is given by 2 into 10 to the power minus 3 sin omega t. 1 minute. This is sigma into S. Sin omega t. 10 to the power minus 3 because it is in milliamperes. 10 to the power minus 3 converts milliamperes into amperes. What is sigma? 10 to the power 7 Siemens per meter into S. So this becomes now 2 into 10 to the power minus 10 divided by S into sin omega t. Unit of E is volts per meter. So conduction current is equal to conduction current density into area of cross section of the wire. So what is J? Sigma into Ohm's law in point form. From here I find E as IC divided by sigma S. IC is given as 2 sin omega t milliamperes. 10 to the power minus 3 factors introduced because milliamperes is converted into amperes. S is given as, S is not known. Sigma is 10 to the power 7 Siemens per meter. So this is the expression for E. Next what I am going to do is, what is displacement current? Displacement current is open surface integral vector dou d by dou t dot ds. So this is nothing but dou d by dou t integral ds. Dot product is dispensed off because vector dou d by dou t and vector ds are normal to each other. So this is nothing but dou d by dou t into what is surface integral ds, area of cross section of the wire. So this is S into dou by dou t. What is d? D is what? Epsilon into E. So this becomes S into epsilon dou by dou t. What is E? E is found here. 2 into 10 to the power minus 10 divided by S sin omega t. So now SS gets cancelled. You get epsilon into 2 into 10 to the power minus 10 sin omega t. If you differentiate, you get omega cos omega t. So this is epsilon is what? 8.854 10 to the power minus 12. 2 into 10 to the power minus 10. What is omega? Omega is what? 2 pi f. 2 pi. What is f given? F is given as 10 to the power 9 divided by 2 pi into cos omega t. If you simplify this, you will get 1.77 into cos omega t. Unit is picoamperes. This is how displacement current is formed. From the given data, you find what is electric field intensity. Then find displacement current as open surface integral of vector dou d by dou t dot ds. This dot product becomes simple product because vector dou d by dou t and vector ds are perpendicular to each other. So surface integral ds is nothing but area of cross section of the wire. Therefore I written it S. Then I written d is equal to epsilon into E. The expression for E is available here. Substitute, differentiate, you get this as the answer. Thank you. Next problem. Show that the ratio of the amplitudes of conduction current density and displacement current density is sigma divided by omega into epsilon. For an applied field, E is equal to E naught cos omega t. Assume mu is equal to mu naught. Let me read out once again. So that the ratio of the amplitudes of conduction current density and displacement current density is sigma by omega into epsilon. For an applied field, E is equal to E naught cos omega t. Assume mu equal to mu naught. Solution. Given E is equal to E naught cos omega t and mu is equal to mu naught. What J is equal to conduction current density is equal to sigma into E is equal to sigma into E naught into cos omega t. JD is equal to displacement current density. Displacement current density is equal to dou d by dou t in the scalar form. Dou by dou t, what is d? D is epsilon naught into E. Mu is mu naught means I have taken epsilon at epsilon naught. So this is epsilon naught dou by dou t. What is E? E is nothing but E naught cos omega t. So this is, I will take, instead of epsilon naught, I will take a general medium and take it as epsilon, because in the problem statement it is given epsilon. So this is epsilon into E naught. Correct. If you differentiate cos omega t, you get minus omega sin omega t. Hence J divided by JD is sigma divided by omega epsilon with a minus sign. This implies modulus of J divided by JD. When you take modulus, minus sign goes off. So you get sigma divided by omega into epsilon, hence the proof. So ratio of the magnitudes of the conduction current density and displacement current density is given by sigma divided by omega into epsilon. Very frequently asked problem for 5 marks. Please go through this problem. Field theory practice at least 3 or 4 times. Otherwise in the examination you will get the same problem but you will be unable to solve. All the problems, all the derivations look similar. Here practice is a must. Thank you. Next problem. The dry earth has a conductivity sigma equals 10 to the power minus 8 Siemens per meter and relative permittivity epsilon r equal to 4. Find the frequency range on which the conduction current dominates the displacement current. Again I read out. The dry earth has a conductivity sigma equals 10 to the power minus 8 Siemens per meter and relative permittivity epsilon r equal to 4. Find the frequency range on which the conduction current dominates the displacement current. Solution. Given sigma equals 10 to the power minus 8 Siemens per meter, IC divided by ID modulus greater than 1, because conduction current should be greater than displacement current. This is same as magnitude of J by JD greater than 1. This implies modulus of J, modulus of, see, from the previous problem we have got J divided by JD modulus is what? Sigma divided by omega epsilon. That result we have to take, or this result to be proved in the examination. You cannot say from the previous problem. Hence, sigma divided by omega epsilon greater than 1. This implies sigma divided by 2 pi f into epsilon greater than 1. This implies sigma divided by 2 pi epsilon greater than f, which in turn implies f should be less than sigma divided by 2 pi epsilon naught into epsilon r. So this implies f should be less than, what is sigma? 10 to the power minus 8. 2 pi Epsilon naught is 8.854 10 to the power minus 12 farads per meter. Epsilon r is 4. So if you calculate this, you get F less than 45 Hertz. When F is less than 45 Hertz, dry earth acts like a conductor. That's what it means. When F is less than 45 Hertz, conduction current is greater than displacement current. Therefore, earth will act as a conductor. In other words, when F is greater than 45 Hertz, displacement current will dominate over conduction current and earth will behave like a dielectric. So, depending upon the frequency of operation, the earth can behave like a conductor or a dielectric. That is the implication of this problem. Thank you. We shall go to the next problem. Do the fields vector E is equal to E naught sin x sin t ay cap volts per meter and vector H is equal to E naught by mu naught cos x into cos t az cap amperes per meter satisfy the Maxwell's equation. Solution. For free space, conductivity sigma equal to 0. This implies conduction current density vector J is equal to sigma into vector E equal to 0. This is the implication. The Maxwell's equation derived from Ampere's circuit law is del cross H is equal to vector J plus vector dou D by dou T. This implies del cross H is equal to vector J is sigma into vector E plus dou by dou T. What is vector D? Epsilon naught into vector E. This sigma is 0, therefore sigma into vector E is 0. This implies epsilon naught into dou by dou T operating on vector E is equal to del cross H. The problem is given in the Cartesian coordinate system. Therefore, write del cross H using the determinants. So this is what epsilon naught into vector dou E by dou T is equal to determinant Ax cap, Ay cap, Az cap, dou by dou X, dou by dou Y, dou by dou Z, Hx, Hy, Hz is the determinant. Say vector E, since vector E is what? E naught sin x sin t into Ey, we have what is Ey? We have Ey is equal to E naught into sin x into sin t. What is Hx? 0, because there is only unit vector Az cap. What is Hy? Hy is 0. And what is Hz? Hz is E naught divided by mu naught into cos x into cos t. Hence equation 1. Also please note that vector H is a function of x only. Since vector H is a function of x only, it implies dou by dou y equals 0 and dou by dou z equal to 0. Thus equation 1 reduces to epsilon naught into vector dou E by dou T is equal to determinant Ax cap, Ay cap, Az cap. Dou by dou x is non-zero, dou by dou y 0, dou by dou z 0, Hx 0, Hy 0, Hz non-zero. This implies epsilon naught into dou by dou t. What is vector Ey into Ay cap is equal to, expand this determinant, you get Ax cap this into this 0 minus this into this 0 minus Ay cap into dou by dou x operating on xz minus this into this 0, Az cap into this minus this into this. Only Ay cap will survive. So minus Ay cap into dou by dou x operating on hz. Ay cap cancels on either sides. So you get epsilon naught into dou by dou t operating on Ey. Ey is what? E naught sin x sin t is equal to minus dou by dou x. What is hz? Hz is E naught divided by mu naught cos x into cos t. Cos t. So differentiate now. This implies epsilon naught into E naught sin x into cos t. Cos x, if you differentiate, you get minus sin x. Therefore, this minus sign gets cancelled. So you get E naught divided by mu naught sin x into cos t. So this implies mu naught into epsilon naught is equal to 1. This is impossible. This is impossible. Hence, vector E and vector H do not satisfy Maxwell's equation. Do not satisfy Maxwell's equation. With this, we finish this problem. So what is important here is, first thing is you must note that vector E and vector H are in free space. How I have got that clue? Because here he has given mu naught. So I have taken medium of propagation to be free space. Free space means conductivity sigma is 0. Therefore, this in del cross H is equal to vector J plus vector dou D by dou T is the Maxwell's equation derived from Ampere Circuit Law. Sigma into E is 0. Then you have to write del cross H in the determinant form. These two variations are 0 because vector H is a pure function of x. These two components are 0 because vector H contains only unit vector Az cap. Simplify the determinant and you will find that mu naught by epsilon naught equal to 1. This is impossible. The mu naught is what? 4 pi into 10 to the power minus 7. What is epsilon naught? 8.854 into 10 to the power minus 1. Therefore, the product cannot be equal to 1. Therefore, written here, this is impossible. Hence, vector E and vector H do not satisfy Maxwell's equation. Thank you.